So one theme in computers is this idea of bulk operation. So we have this right now with the for loop. So you can write a little bit of code, and the computer takes care of running that code thousands or millions of times across some big data set. So another theme is this idea of logic or selectivity. So for this, we're going to be able to write a test which is true or false, and then use that to control if a particular piece of code runs or not. And so that in JavaScript is done with a thing called the if statement, and that'll be the subject of this section. Combining the if statement with the for loop gives us a very powerful combination, both the sort of reach to cover a lot of data and the selectivity to sort of pick exactly what we want to do with different parts of the data. So that'll work. That'll allow us to work on many interesting problems. So here's the syntax of an if statement shown in the context of a for loop. So it's right here. So it starts with the word if, and then that's followed by a part called the test, which appears inside of parentheses. And we're actually going to spend most of our energy sort of playing around with the test. In this case, the test says if pixel.getRed is greater than 160. So for now, our tests will pretty much have this form, basically comparing one number versus another number. In this case, I'm using greater than, or the other one going the other way is the less than. So what this does is obviously just tests for this pixel. Is the red value over 160 or not? So that's just true or false. The way the if statement works is that the test is followed by a set of curly braces, just like for the for loop. And inside the curly braces, I'm going to call that the then code. And the then code could just be any lines of code we want. So the way the if statement works is that when it runs, it evaluates the test, and the test is going to be essentially for each pixel. This test will be either true or false. If it's true, the if statement then goes ahead and runs the then code, whatever that says to do. If the test is false, then the then code is just skipped. So the if statement works as kind of a switch to just either enable or disable the code inside the then block here. So this pattern of having the outer loop to look at all the pixels, and then inside of it putting an if statement to sort of control what we're going to do in certain cases, that's going to work to solve many interesting situations. So the first problem I'll look at here is the stop sign. So suppose I want to take the stop sign and I want to change all of the red in the sign to be blue, so it just looks like a stop sign from Mars. So my first attempt at this is I'm going to write the test. My test will be if pixel.getRed is greater than 160. So that's just checking if the red value is kind of large. And so that's here. And I can do whatever I want in the then code here. In this case, I'll just set red and green to 0 and blue to 255. So that'll give us that kind of blue appearance. All right, so let's just try that. So if I run it. So you can see it kind of works. The red parts of the sign have been certainly obliterated to look all blue. And then we've got some areas over here and areas over here as well. I should say this technique it's an okay technique, but we're going to refine it to come up with something a little bit better. One thing I want to show is that this 160 here there's nothing really magic about that value. For code like this, you would expect to sort of play around with different values and sort of adjust it so it looks the way you want. So let's say I want to have less blue here. Then what I would want is to make this test more restrictive. Now, the way you can think about it is that it's going through thousands of pixels, and for each one, it's checking the red value. And in this case, to say that the red value is over 160, it's sort of a hurdle. It's like it has to get over the 160. So if I were to put a bigger number here, like let's say 200, and I run that, well, there's not much difference, right? Let's try even bigger. How about 240? I run that. There we go. You see what's happened is I've made the if test more restrictive, sort of fewer pixels get by. And if I make it up to 250, really raise that thing, then the great majority of the pixels don't get past the if statement. There's just a few remaining pixels scattered around here that are red enough to get past that test. So it could go the other way too. So instead of 160, I could go down to let's say 100. I'm going to lower the hurdle. And in that case, then yeah, way too many more pixels than I want end up making the test. So that's kind of a typical step for a lot of the problems we're going to look at, where we'll have some we'll have some structure we want, and then we'll be left with some number that we kind of tweak up or down a little bit to get it the way we want. The other thing I can show here, I'll set this back to 160, is the code. The then code could just do whatever. It's under the control of the if test. Here it just sets it to blue, but I could just as easily say, well, let's set red, green, and blue all to 0. And if I run that, then we get a sort of a black stop sign instead. So we'll use that creativity later to put different sorts of code in the then section. All right. So let's scroll back here. So this kind of works. I'm getting the red sign, but I'm also getting, it turns out I'm getting all the white parts of the sign as well. Our test effectively gets both red and white. And you can see that most clearly if you just scroll back to see what the sign looked like originally, right? It's got these red areas, but it's also got obviously these big white letters. And we're just getting all of that. And if I look at this test again, you can sort of see why that is. Well, I'm checking if red is greater than 160. And so when does that happen? Well, one time that happens is for a red pixel, a pixel that we think of as reddish, where the red value is going to be high and the green and the blue will be kind of low. So it'll be, let's say red is 200. It'll be true then. But what about the white pixels? So a white pixel might have values like maybe red, green, and blue are all 220. All three numbers are high. And because my test just looks at red and says, is it greater than 160, it's going to trip for the white pixels as well. Both the white and the red pixels, for both of those, this test will appear true. It fails to distinguish those cases. And that's exactly what's happening here. The red areas and the white areas both have red values of high that are high, and so this test just, it's not quite distinguishing those cases. So we want to do a little bit better. So I'm going to build up a better strategy that we could use to solve this problem. So to get started, I'm going to make sort of a graphical view of a pixel. Suppose I've got 3 pixels, and each pixel obviously is going to have red, green, and blue values. And so suppose what I did is I made this little bar chart. So here's a pixel at the left, and here's a pixel in the middle, and here's a pixel on the right. And all I've done is I've just graphed the red, green, and blue values. And so for any one of these, I could ask, well, for that pixel, which color predominates? What sort of cast does it have? So here, for this pixel, I'd say, well, it's red. Right? You can see the red just sticks up the most. For this middle pixel, I would say, well, blue. It has kind of a blue cast. And here, this pixel, even though the pixel itself is much darker, I would say that it has a greenish cast. And in all 3 of those cases, what's going on is, I think intuitively, we're kind of looking at the 3 bars and asking, well, which one pokes above the other 2? And that is a reasonable way of thinking about, well, what color cast does that have? So I'll remind you, sort of, I have to bring in here. In the last section, we had this idea of the average of a pixel. So the average was going to be averaging the red, green, and blue values to come up with sort of an average between those 3. And so I can combine that with my little bar chart here, where for this first pixel, I could take the red, green, and blue values and average them, and I can think of that as sort of a line. And the line is going to be kind of in the middle of the heights of the bars, because it is, right? It's going to be shorter than the tallest one and taller than the shortest one. It's going to be kind of in the middle somewhere. So with the average, it allows us to pursue the earlier strategy, but now it's a little more concrete. We'd say like, well, right, this first one is reddish, and we see that the red bar is poking above the average and the other 2 aren't. And this middle one, we see that the blue bar is poking above the average, and here we see the green bar is poking above the average. So that just gives a kind of a little intuition about how it is I could decide what cast a color has. The nice thing about the average is it's just a number. It's just a single number, and so it's going to be pretty easy to incorporate into an if test. So for example, if I could write the test if pixel.getRed is greater than average, right? GetRed is a number, average is a number, and then if you look at this left pixel, it's going to be true. Yeah, the red is greater than the average. And for these other 2 pixels, it's going to be false. In both cases, the red is below the average. And so this suggests sort of the strategy I'm going to pursue for detecting what cast a pixel has by first computing its average, and then if I want to look for red or green or whatever, comparing that to the average to decide if that cast is present. And this is going to work pretty well. So let me revisit my stop sign problem. And now what I'm going to do is for the test, as I was describing earlier, I'm going to write the test as pixel.getRed greater than average. And then actually I'm going to multiply times sort of an adjustment factor. Just using the average just by itself is really exactly what we want. We want some sort of a number that we can tweak. So here's the real code down here. So I'm looping over the whole image. As in the last section, I'm going to just compute the average between the red, green, and blue, so I can use that for my comparisons. And then here, I'm going to write the if test, as I've said, well, is the red greater than the average, and then this sort of adjustment factor that we'll play with. All right, so let's try that. All right, so what we see is we're getting the sign pretty nicely, but then, there's way too much extra blue over here, and this is just, we have to fix the adjustment factor. So I'm just going to try making the hurdle a little higher. So if I say 1.3 here, make it a little higher, then that cuts it down. We still have a little bit over here. I could go up to 1.8, make the hurdle much higher. Okay, well, you see I get the sign, but I lose this four-way thing here. Apparently those are slightly different shades of red. So I'll go down to, let's try 1.4. There, I think 1.4 looks pretty good. Right, where there's a little bit of blue here, a little bit of extra coloring over there that I'm going to tolerate, but it seems like in terms of the sign, we've dialed in on the red areas pretty nicely. So that shows this technique working pretty well. I should just show that this factor, you could also try numbers less than 1, so I could try like 0.9, and then it's like super permissive. So I'll put this back to 1.4. There we go. That's nice. That's dialed in on the sign. All right, so let me try a second example of this technique. And I want you to imagine that you're visiting Stanford sometime and you park here and you get a parking ticket. Now, philosophically, we know it's best to sort of take in the world as it has actually happened. Don't think too much about what you wish had happened. However, in this case, we're going to try and fix history in code. So what I want to do is take this picture and fix the red curb to not be red anymore, to be gray. So here's the code for that. We'll try different variants of this. So I've got curb.jpg is this image. And I'm going to loop through all the pixels and compute the average. And so now we're left with the test. So I'll say if pixel.getRed is greater than average or whatever here, we'll start with a factor of 1.5. And as my first attempt at this problem, what I'm going to do is set the pixels to just sort of a middle gray. So 120, 120, 120. We'll just sort of paint gray on there. All right, so let's try that. All right, so what we see is we're getting too little gray here. So when you're adjusting one of these if tests, you always want to think, well, do you want to make it more or less restrictive? In this case, I want to make it less restrictive, right? I want to get the gray going along here. So I'm going to make the hurdle lower. So I'll try 1.4. Yeah, that's getting there. Let's try 1.3. Yeah, keep going. 1.1. Oh, too far. Okay, 1.2. All right. So this does a pretty good job. I've identified the red curb over here and like put this sort of flat 120, 120, 120 gray on there. If you look carefully, I'm also catching a little bit of parts of the plant that I guess had a little bit of red cast. And actually, over here on the right-hand side, there's these plants that I guess had sort of a red cast, and I'm glopping them up with this gray. So this is it's pretty good. But what it says in the problem statement here is actually for part B, what I'd like to do is instead of just changing this to 120, 120, 120, I want to use the technique from the previous section where I say, well, look, let's take the red parts of this image and change just those parts to be grayscale. Previously, I did an example where I would change an entire image to grayscale. Now I'm using the if test to just pick out certain regions of the image and just change them to grayscale. And it just turns out this will look better. Well, let's just see. So remember, the algorithm to change a pixel to grayscale is to first compute the average for that pixel, which actually I'm already doing here. And then with that average number in hand, then set the red, green, and blue values of the pixel to all be that average. It happens for this code, that's a very small change. Instead of saying set red 120, I'll just say set red AVG. And likewise, green AVG and blue AVG. All right, so let's try that. There we go. So you can see here, I've mapped, right? I've sort of put gray on here. And it looks a lot better because really this red curve does have a pattern of light and dark on it. And by changing each pixel to be gray, but we're still respecting the light and dark. So that's why it looks better here. Also notice the plants over on the right hand side here that looked so bad before. Well, they were red plants before. Now we've changed them to kind of gray plants, but I think you sort of can't tell where it looks fine. So I think that's a nice solution. All right here. So this just restates what I was just saying there. So I'd say the conclusion for this section is mainly just the idea of an if statement that combines a test with some then code under the control of that test. And then I've done a couple examples using this particular technique to detect pixels of a certain color in an image. So, my standing example of a pixel.getRed greater than average times some factor, and using that to kind of dial in on pixels of a certain color. And then finally, we've seen that the then code can sort of do anything. It can change it to blue or change it to red or gray or whatever. And certainly we'll take advantage of that flexibility for solving lots of problems.